All right. So you guys have been introduced a little bit to absolute values. I had in 1.1, you guys had to simplify a couple expressions with absolute values. Today we're going to be doing, and in 1.2 also. Today we're going to be adding to that quite a bit. We are going to be solving equations with absolute values. Okay, there's no goal on here. So our goal today is to solve absolute value equations. Does anyone remember the distance? The definition for absolute value? It is a distance. Anyone remember? Go ahead.
The exact distance from 0.
Yes, the distance from 0. Okay, so that's how it's defined. The absolute value is going to be the distance away from 0. On a number line. So if I asked you to evaluate the absolute value of -5, how far away is -5 from 0 on a number line? 5 away. So it's 5. Or what is the absolute value of +5? Also 5 away. So both of those answers are going to be 5. And I wanted to do something simple like that because so you guys remember what does absolute value look like? How do you treat it? These straight up and down brackets, those are absolute value brackets. So that's something you guys have worked with in the past. But seeing that example of how to evaluate with absolute value bars, if I said I took the absolute value of a number and my answer was 10, okay, what would be the possibility that x could be? -10 or 10. You have two options because it's saying what number has a distance that's 10 away from 0. Well, on a number line, you can go 10 to the left and be at -10, or you can go 10 to the right and be at +10. So for that answer, when we find this answer, this breaks up into two scenarios, and you have that x could be -10 or x equals 10, and you get two solutions. All right, so we have our first example that is, supposedly it's our second example, but it's the first tricky one. We should actually plug this back in and check to make sure that it works. So to check our solution, we can plug in -10 equals 10, and you have to simplify the left, and when we simplify the left, we get 10 equals 10, and that works. Okay, we plugged in -10, now let's plug in 10. The absolute value of 10 equals 10, that's 10 equals 10, which also works. So I can see both of those are a solution. You'll want to get in the habit of that because when we were solving equations before, if it was not a solution, then you did something wrong and you had to go back and figure out what went wrong to find the actual solution. Okay, but we have some information about that in an example in a little bit. All right, so the first step that we have to go about, we'll write our steps off to the right, and we'll actually do them off to the left. So our first step is to get the absolute value brackets alone. So what am I going to do over here to get the absolute value brackets by itself? What's happening to them right now? What is it? Adding 7's on the inside. I'm not going to be worried about what's on the inside. I just want to get the brackets themselves by itself. So what's happening outside the brackets, that's what I'm going to have to get rid of. So what's happening on the outside of those brackets? Go ahead.
You subtract 4 from 4 and 3.
Yep, we're going to have to subtract 4 because it's adding 4. So we have to undo that part of it, what's outside the brackets. So subtract 4 on both sides. Now we have the brackets by themselves is set equal to 16. Okay, so whatever this is on the inside, I don't really care, but I know I took an absolute value of a number and I said that it was 16. So the distance away from 0 is 16. What two numbers are 16 away from 0? Yeah, negative 16 and 16. So that means whatever I did right here, I'm either going to get 16 on the inside of there or negative 16 on the inside of there. So the second step is to remove, I should do this in a different color. Remove the absolute value bars, and you break this into two scenarios. And the way I always think about it, I always think those brackets come down into the arrows, which create the two scenarios. And I know that either that inside was 16 or the inside was negative 16. Because if that was 16, the absolute value of 16 is 16. And if that on the inside was negative 16, then the absolute value of it would also be 16. Are we okay so far? And I think you guys did some of these in Algebra 1. You guys did like simple versions of this in Algebra 1. Okay, so we'll get into a little bit trickier than what you guys did in Algebra 1, but it's the same idea, the same concept. All right, so our next step is to solve each scenario. So that's just like what we were doing before with solving equations. So we're getting x by itself. And we think we have the solutions. However, whenever we are solving absolute values, you have to check your solution. And you have to. Like, it's not an option. It's not that if I did this really well, then of course those are going to be my answers. Because sometimes you're going to have what we call extraneous solutions. And an extraneous solution is something that looks like it's going to work, but then it doesn't when we plug it back in. So you could have solved it completely accurately, but it's not an actual solution. So that's what you have to figure out. If it's a solution or if it's extraneous, that means it's not technically a solution. So we need to actually plug these back into the original to verify if they work. So we'll plug in the 9 first, and we have 9 plus 7, the absolute value of that, plus 4 equals 20. Now, remember, pretend that the right side's not there. You're just going to simplify the expression on the left side. The first thing we're going to do is simplify what's inside the brackets. Plus the 4. Now take the absolute value of 16, and you have 16 plus 4. 16 plus 4 is 20. And on the right side, I still have equals 20, which that is true. That tells me that x equals 9 is a solution. So I'm going to put a check mark. All right, now I'm going to do the same thing, but this time with negative 23. So from the beginning, I have negative 23 in for x, plus 7, add 4 to that, equals 20. Pretend the right side's not there. We're going to work at simplifying that left side. Inside the brackets, we have negative 16 plus 4 The absolute value of negative 16 is 16 plus 4. And I again have 20, which is equal to 20. And that one is also a solution. So I can see in this case I have two solutions, and those are my two solutions. Am I good to move it on to the back? Okay. Now this back one, we're actually going to see, I'm going to let you guys know right now, that there is going to be an extraneous solution. So we'll see what that looks like then. So remember, the very first step says to get the brackets by themselves. Okay, so we have to get the brackets alone. But wait, the brackets are already alone. Do you see that? So then what's our next step say to do? Yep, we're going to remove those bars and we're going to break it up into two scenarios. Now, those absolute value bars, I always tell my students, they're like brick walls. It takes a lot of work to break those down, and we have to break them into two scenarios. So when I break them down, I pretend that those absolute value bars broke down into the arrows. That was so much work on that side, there's nothing else I can do because I don't have the energy to do it. So that side does not change. It stays 3x plus 10. Okay, and in this scenario over here, I have 3x plus 10. But on the right side, it either equals the original, so 4x plus 7, or the opposite. So there's that language from 1.1. What would the opposite of 4x plus 7 be? Go ahead. Yes, you have to negate both terms. When you're coming up with the opposite of an expression that has two terms, you have to make both terms opposite. Are you guys with me on that? Okay, so this one, the left side, you didn't do anything. All you did was remove those bars. Those were like brick walls that you had to tear down. It was so much work, you couldn't do anything else on the left side. But the right side is where you have the two scenarios. You have the original and then the opposite. Okay, so then our step after that is to do what? What do we do now that we have these two scenarios? How about we just solve them? Solve the left one first, then solve the right one. So go ahead right now. Let's solve the left and then solve the right. Let's see what we get. How did we do? Were we able to get those two solutions? Okay, now, here's where we don't know if they're solutions or not yet. We're going to actually have to check for extraneous solutions by plugging them back into the original. Are we ready? Okay, so when I plug in 3, now don't get scared with that fraction because it'll be okay, I promise. All right, so up here, that's where we're plugging it in. 3 times 3 plus 10 is equal to 4 times 3 plus 7. So again, remember, you just do one side at a time. So cover up that right side, and we're going to simplify the expression on the left side. This is the absolute value of 9 plus 10. the absolute value of 19. And the absolute value of 19 is 19. Equals. Now we're going to cover up the left and we're going to simplify the right side. 4 times 3 is 12 plus 7. 12 plus 7 is 19. So we got 19 equals 19. And that tells us that when we plugged in 3, it worked. So that is a solution. Okay, so we have to plug in this fraction up here. So we have 3 times negative 17 over 7 plus 10. And on the right side, we're going to have 4 times negative 17 over 7 plus 7. Okay. Multiplying by a fraction. This just multiplies into the top, so negative 17 times 3 is negative 51 over 7. Yep, negative 51 over 7 plus 10. Remember, we're ignoring the right side. We're just simplifying this. All right, adding 10 to that. At this point, because I'm not really worried about getting a final answer here, okay, that I'm going to write my solution as, I'm really just checking my answer. I don't care if you actually use a calculator and say that inside this is approximately 2.714 dot, dot, dot for right now. Okay, that's okay when we're checking a solution if you are to use decimals. Okay, we're just checking. The absolute value of that is still going to be that same number. Obviously, we make it positive if it wasn't. That's already positive, so it's still positive. Okay. If we ignore the left side, again, I don't care if you want to figure this out in all fraction form or if you want to go right to putting it in your calculator, that's fine. So 4 times negative 17 over 7 plus 7. And we get negative 2.714 on the right side. Dot, dot, dot. Is that a true statement? No. That means that our solution is extraneous. Okay? So this solution right here is actually not a solution. Yes, we solved it completely accurately, but the absolute value symbols can sometimes have extraneous solutions. So that is an extraneous solution. So it's important that you go through and you actually check for extraneous solutions. Okie doke. All right, so on a test or quiz, it might look like this. Solutions and extraneous solutions. Okay, if something is an extraneous solution, that does not make it a solution. So do not write it up here. So in this case, what I would write is I would write x equals 3 is a solution, and for my extraneous solution, I would just write x cannot be negative 17 over 7. It means I found this to be a solution, but it turned out it wasn't a solution. Does that make sense? Okay. Last example. We have the absolute value bars. The first thing we have to do is to get them by itself. Now, if this looks really stressful, pretend this said 6x plus 10 equals 100. And how would you get x by itself? So think about it in a simpler way. If you're trying to get those brackets alone, what you would do if it was just one variable there. 6x plus 10 equals 100. Sometimes that helps people visualize how would I go about solving for x instead of how would I go about getting those brackets alone. Does that make sense? So what would be my first step in getting that variable or those brackets alone there? If you divide by 6, you have to divide this term by 6, divide this term by 6, and divide that term by 6. And knowing 10, I don't think I want to divide that by 6 yet. So what would I do first? Subtract 10. Yep. So subtract 10 on both sides. That gets rid of that. Then I have 6 and those brackets left equals 90. Inside those brackets, I have 4b minus 7. And now what should I do? I still have to get the brackets alone. So if this said 6x equals 90, how would I go about getting the x by itself? Divide both sides by 6, right? So divide the left by 6, divide the right by 6, the 6's go away. Here my brackets are alone. And 90 over 6 is 15. Okay. All right, now that the brackets are alone, what comes next? Break it into your two scenarios. So remember, these are like brick walls. It takes a heck of a lot of energy to break those down, so we can't do anything else on the left side. So we have 4b minus 7 on the left and 4b minus 7 on the left. The right side, though, what are we going to have on the right side for this? What is it going to be? Yep, you're going to have the original, which was 15, and the opposite, which is negative 15 in this case. From here, you're just going to do what you've always done in solving the two equations. Now in this case, you don't want to go to a calculator here. You want to leave it as a fraction for your answer. You can reduce it 11/2, but you're not going to type that into a calculator. Okay, so there's one maybe solution. We'll know when we check our solutions. Okay, so we have two maybe solutions, but we still have to check those. So we're going to plug them into the original. So 6 times 4, our b value was either 11/2. We'll come back and do the other one in a minute. So remember, ignore the right side, and we're going to simplify the expression on the left. So we start inside the brackets. We'll have to do the multiplication first, and then subtract. So this will be 4 times 11 divided by 2. So 44 divided by 2 is 22. So that actually worked out nice. Plus 10 still. Still inside those brackets, 22 minus 7, we're going to get 15. The absolute value of 15 is still 15, so this just turns into 15 in parentheses then. 6 times 15 is 90 plus 10, which is 100 on the left, which was the same thing as the right. There was nothing to simplify on the right, which tells me that check, that is a solution 11 halves. Now we're going to do the same thing and plug in -2. So 6 times 4 times -2 minus 7. Add the 10 on the outside. And this is supposed to equal 100. So ignore that equals 100 part. We're going to simplify this expression, working from the inside of those absolute value bars first. So 4 times -2 is going to be -8. -8 and -7 is -15. 6 times the absolute value of -15, that's going to be a positive 15. So 6 times 15 plus 10. Which is exactly what we had right here. So we do know this is going to be 90 plus 10, which is then 100, which is still equal to the 100 that was on the right, and this is also a solution. Okay. There is a way that you could do a shortcut here. Okay, so if you notice, and there's none in any of these examples, but let me show you what I mean. If you notice that you have an absolute value, I don't even know what it would be in here. Absolute value bars, and they're set equal to a negative number. If you get the absolute value bars alone, and it is set equal to a negative number, what can you take the absolute value of and find -15? What number can you take the absolute value of and get -15? If you're not answering because you can't think of one, it's because there is nothing. You'll never take an absolute value of anything and get -15. So you could go and solve this and break it into your two scenarios and have them be there. But what's going to happen is you're going to get two extraneous solutions. So instead of doing all that work and finding solutions that don't even work anyways, as soon as you see absolute values equaling a negative number, we can say that this is no solution. Now that's only if it's a negative number. If it was like -x, it will not work because x could be a negative, and then you'd have negative of a negative, which is a positive. We don't know when it's a variable because a variable represents a number. So this only works if it's set equal to a negative number. Does that make sense? So that's going to be a shortcut. And then you don't have any solving and plugging in to do if you see and notice that that happens. Okay. So that's it.